This is a great problem. If you invest $550 a month into an account that earns 7.7% interest compounded monthly, how many years will it take for the value of the account to reach $40,000? Round your answer to the nearest tenth. Okay, so right here we see that we're putting a certain amount of money into an account and we want to know when it reaches $40,000. So that's going to be a future value problem. So I want you to write out the formula for future value. So FV equals R times 1 plus I to the n minus 1 over I. Okay. So I always say write out the formula because it's going to be helpful, because then directly below I want you to write all of the variables in the formula out and then their values. Obviously one of them won't have a value, and that's the one we're solving for. So future value is the future value of the investment, which is going to be 40,000. Okay. And then R is going to be the value of the periodic payment. So how much money are we putting in? And we're going to be putting in $550 per month. And then our next variable is I, and I is the interest rate per compounding period. So you may know that as R over K, which is the interest rate, 0.077, over K, the number of times it's compounded per year, and in this case it's 12 because it's monthly. And then our last variable is N, which is the number of periodic payments. So how many payments are we making in total? Well, that's going to be the number of payments that we make per year, which is K, also the number of times compounded per year, times the number of years, which is T. So K is 12, and T we don't know. So that's what we're solving for right there. Boom. Okay, so now that we've organized this so nicely, we're now going to plug everything in. Okay, so we're going to use the formula and just plug it in. So FV is 40,000. And that's going to equal 550 times 1 plus 0.077, and make sure you write it as a decimal, to the 12t, and then that whole quantity minus 1, and then over 0.077 over 12. Perfect. Okay, so now we need to get t by itself. So we're just going to do some math. So let's get rid of this 550 first. So because it's attached to this multiplication, I'm going to do division to undo it. So see you later. Okay, and 40,000 divided by 550 is going to be 72.727272. And if you have a calculator, you can just store these values so you don't have to write them all down here. Okay, and then that's going to be equals 1 plus 0.077 over 12 to the 12t minus 1 over 0.077 over 12. Okay, so next, this denominator, I'm not liking it. So how can we get rid of it? We can just multiply by it. So if we multiply the numerator by it, or this side of the equation by, oops, not over 0, over 12, okay? We can say check your later denominator, and then we just have to remember that we have to multiply the other side, because whatever we do to one side, we have to do to the other. Boom. Okay, then this is going to equal on this side. We're going to end up with 0.466667, and that's going to equal. Now at this point, I'd also like to maybe simplify this into a decimal, just get it out. And that's going to be 1.006417, okay, to the 12t. And then we have this minus 1. Okay, so that's easy. Again, just add 1 to both sides. So now we're looking at 1.466667 equals 1.006417 to the 12t. Okay, so I'm running out of room here, so I'm just going to move up a little bit. Okay, so we can see everything that's going on. Okay, so now we need to get that t down. We need to get that t down. So you may remember your properties of logs. Okay, so I'm just going to refresh your memory over here. Okay, the power rule, and that is the log base b of a to the c equals c times the log base b of a. So basically, we can use this property to bring the exponent down in front. We could write it as the log base b of a to the c, or we could write it as c, bringing the c down in front, times the log base b of a. So let's think about it. If we just take the log of both sides, and I'm just going to do natural log because I personally like that one, we can bring this 12t down. So I'm going to take the natural log of this side, and then of course if I do that I have to do it to the other side, otherwise I'm changing the value of the equation. Okay, so now when I take that natural log, boom, this 12t is going to come down in front. Okay, so take a look at the next step here. This is the hardest part of this problem, I think. So I'm taking the natural log of this, so you know what, I'm just going to actually do it and write out the decimal, which is going to be 0.382992, 382,992, and that's going to equal, remember the 12t comes down in front, so 12t times the natural log of 1.006417. Okay, oops, I forgot the t here, 12t, sorry. Not just the 12 that comes down with the 12t. Perfect. Okay, now the natural log of 1.006417 is a number, so let's just get that number. So again, on the left side here, I've still got this, and then I've got 12t on the right times, and then a number, which in this case is 0. The natural log is going to be 0.006396. Perfect. Now this is all multiplication, so I can multiply the 12 and this number together, okay? And that's going to equal 0.076758, and then of course times t, and that equals 0.382992. Oh my goodness, we are almost done. This is awesome. I'm solving for t. This is just this number times t, so I can undo the multiplication by division. Okay, divide both sides by 0.076758. Okay, and I end up with 4.989605, and that equals t. So then because I said round to the nearest tenth, that's going to round to 5.0. Okay, so it will take you approximately 5 years to save the $40,000. Okay. And I always say, write it out in a complete sentence, because you're not going to walk up to someone on the street and just be like, t equals 5.0. Like, you need to know what that actually means, okay? So always write it in a nice, complete sentence. Look at that. You are a total math superstar. Seriously, look at all the work that you did, and it looked so daunting, right? It looked so daunting in the beginning. You were like, how am I going to ever solve this? It's so complicated. Let's just take a look at it again because, well, you know, it looks pretty intense, okay? So I think that you should be very proud of yourself. Look at this. Look at where we started. I mean, we can even make the argument that we started with the word problem, which was confusing in itself, but look at this. You solved this for t. You are a total math superstar. All right, so now you can show everyone. You can be like, look what I can do, look what I can do, and then you can help your friends, and then we can all be math superstars. So nice work.